Okay. I think that means it's recording. All right, so let me just be absolutely sure it's recording. Recording, okay, good. So in the tradition of what we do in this lesson, we're just gonna go over some homework questions. This lesson today is all about what's called confidence intervals. So basically, what it does is it gives you a lower bound and an upper bound for what we think the mean is. Let's deal with the mean first. So what we think the mean is based on some information, like on number one, we have 31 textbooks weights and they have a mean of 33 ounces. So we want to know a 99% confidence interval for the true population mean. So what we're gonna do is we're gonna calculate this confidence interval, and then we're gonna be 99% certain that the true mean of the weight of a textbook is between those two numbers. So that's all there is to confidence intervals. There's really nothing more to it than that. So it's just going to describe how to do the problems now. So we're basically going to use two different operations in this first homework from the calculator. So let's do it. Ready? So you measure 31 textbooks weights and find they have a mean weight of 33 ounces. Assume the population standard deviation is 6.5. So whenever you see those words, if they give you the population standard deviation, they give us that, we're going to use the Z interval function. So we're going to use the normal distribution to do that. Okay, the Z distribution, another word for normal. So whenever we have that population standard deviation, that's what we're going to use. We're going to talk about what we're going to use if we don't here in a few minutes. But so what we do, we have a 99% confidence interval, true population. So we need to find out what the true mean is between 99% certain the true mean is going to be between these two numbers that we come up with. So I'm going to go to stat on the calculator, and that Z interval is under tests. So you go to tests and you're going to see a bunch of different tests. You got the Z test, the T test, and down on number 7 is 1 and 2 are going to come into play big time next week. But we go down to number 7 and we're going to do the Z interval. So the Z interval and the T interval are going to give us confidence intervals. All right, so then hit enter. Then we're going to enter what we know. We don't want to input data. There'll be some that we do that. We want to input stats. So I go over and select stats. I hit enter. And now I'm going to go down and put my standard deviation in. So my standard deviation is 6.5. And then the mean, the X bar is going to be that 33. That's what we got it for a mean. And then my N, that's the total number of textbooks we measured. That's the size of the sample is N. That's 31. And then we want a 99% confidence interval. So that C level is going to be 0.99. So then we go down to calculate. And we come up with those two numbers. So we are 99% certain that the mean weight of any textbook is between those two numbers, or the mean weight of the whole population of textbooks. So then we just enter that in, and lo and behold, we got it. So if you two have any questions, just say, yo, I got a question, or I don't really have the chat. I can't see the chat. So if you chat at me, say, hey, I chatted at you, and I can look at it.
I missed what you did on the calculator to get to where you're at.
You can't get the calculator for the Z interval?
Well, how did you get there?
So let's do number two is the exact same problem with different numbers. So
Okay.
I'm gonna show you. So, you got 20 textbooks weights and we have a mean of 66. And then the population standard deviation is 8.6. So those are the buzzwords that we see: population standard deviation. We're going to use Z interval. So to find Z interval, I hit the stat button on the calculator. You could see my calculator, right?
Yes.
Okay. So I hit the stat button on my calculator, and then I go over to the right to tests. And then number 7 down there is the one we want. So we go down to number 7 and hit enter. And then it comes up with this screen. Now, if you had a set of data, we would input the data instead of the stats, but we're given the stats. We know the standard deviation, we know the mean, we know the end value, so I'm going to stick with stats. So then I go down here and the standard deviation this time is 8.6. Textbooks again, all right. And then, what's that?
Super quick question, I'm sorry.
Sorry.
So on my calculator, it has the standard deviation, and then under that it says list, and then under that it says frequency.
You gotta go over to stats on the input.
Well, I mean,
you have data selected, so you want to scroll over and select stats.
I think I'm on the right one. And then you just go to tests and then.
Yeah, so stat. Yeah, that screen, then go over to tests. And then go down to Z interval, number 7. Hit enter. And then you.
Okay, sorry about that. Yeah, cool. Thank you.
Yeah, no problem. Okay, so then I'm gonna put my standard deviation in 8.6. Then my mean for those textbooks is 66 ounces. It's a much bigger textbook. And then I only measured 20 of them, and I want a 95% confidence interval. So this time we go 0.95. And then enter on calculate. And there is my confidence interval for that. So 62.231 and 69.769. We're finding a confidence interval for the mean. So that's going to be the drop-down menu. I'm going to select mu for mean. And there we have it. Okay. All right. Number 3 is the same exact problem again. So we've done 2 of them. So we'll move on to the one after that. So you're going to do number 3, the same exact. In fact, it's textbooks again. A whole different set of textbooks with a mean of 55 ounces. I don't know. I think they get more creative. All right. Number 4. Now we get into a different situation. A researcher is interested in finding a 98% confidence interval for the mean number of times per day that college students text. The study included 96 students who averaged 44.6 texts per day. The standard deviation was 16.7. Round answers to 3 decimal places were possible. Okay, so in this case, there's another distribution that came up called the student T distribution. And I can't remember who it was. I think Wendy explains it. It's in the textbook, the person that came up with this. But they're like, well, if we don't know the standard deviation, how can we use the Z distribution? We really can't. So he came up with this thing called the T distribution to handle it if we don't know the population standard deviation. And if the sample's not too big, 96 students is not a big sample. All right, I'm not sure what they use for a a lower bound, but it doesn't 96 is not a big sample. So we go to T distribution. And now with 98% confidence, the population mean of Texas between blank and blank. So same exact process that we just used, except this time we're going to use the T interval. So I go to stat, over to tests, and it's probably going to be number 8. Yeah, number 8 is the T interval. So we're going to use that one instead. And the T interval just takes into account the fact that we don't know the population standard deviation. We do know the sample standard deviation, which they're going to ask you for. So same thing, we input the data or the stats. We have the stats in this case. We're going to do one where we input the data. So we enter the stats. X bar is 44.6. This problem must have been written when you had to pay per text. And then our standard deviation was 16.7. And then we surveyed 96 students. So we go down, N is 96. We want a confidence level of 0.98. And then we calculate. So I got 40.567 to 48.633. Then part C, if many groups of 96 randomly selected members are studied, then a different confidence interval would be produced from each group. Now, all you do for this part of every one of these problems is what did we assume for the confidence interval? We assume 98% for this one. So we're going to say about 98% of these confidence intervals will contain the true population number of text per day, and about 2% will not contain the true population mean number of text per day. So that just straight up comes from the 98% confidence interval. And lo and behold, we did it correctly. All right, what questions from that? What do you think? Any? Do one more of those? Okay, moving on to 5. 5 looks very much like 4. So we'll do this one and then we'll probably, I think we're going to skip number 6 because I think number 6 is the same as, oh no, 6 has got the data. We're going to do 6 too. All right, fitness center is interested in finding a 95% confidence interval for mean number of days per week that Americans who are members of a fitness club go to their fitness center. Records of 252 members were looked at and their mean number of visits per week was 2.5 and the standard deviation was 1.9. Okay, we're not given any information about the population standard deviation. We just have the sample standard deviation. Therefore, we're going to use the T distribution again. So here we go. Stat. Tests. It's number 8, so I'm just going to hit number 8. And that's going to get me, that's another thing you can do. You don't have to hit the scroll button. You just tap number 8 and it's going to bring you to what you want. Okay, we want to input stats again. Our mean was 2.5. Our standard deviation was 1.9. We surveyed 252 members and our confidence interval is 0.95. So we calculate that and we're 95% confident that the true mean is between 2.2643 and 2.7357. Okay. And then same thing down here. I mean, 95% of the time, the confidence interval will contain true population mean of 5%. That's because of our choice for confidence interval. The higher the confidence interval, the higher the number, the wider it's going to get, right? more confidence means less accuracy. Just to test that theory, I'm going to switch that to let's look at that again, this time do it 98%. So 2.2198, because we wanted to be more confident, it had to encompass more numbers. So the lower bound is lower than for the 95%, and the upper bound is higher than for the 95%. Has to encompass more numbers if we want to be more confident. All right, moving on. Are you ready? Okay. You are interested in finding a 90% confidence interval for the mean number of visits for physical therapy patients. The data below shows the number of visits for 14 randomly selected physical therapy patients. Round the answers to 3 decimal places where possible. We know nothing here. We don't know the mean. We don't know the standard deviation. We're going to use the t-distribution. So now they give us a list. So what we're going to do is we're going to put that list into one of the lists in our calculator. So I'm going to go to stat, edit, and then I'm going to go up and I'm going to enter that list into L1. Remember, to clear a list, you go up, select the L1, L2, L3, what have you, hit clear, enter. And that's going to clear the list. Now I just enter the numbers. So whatever numbers you have, you can enter. So if you enter one number here wrong, it's going to mess the whole problem up. So if you get it wrong, go back and check. Make sure your list has everything in properly. See, maybe I'll get it wrong and we can figure out how to do that together. So now I have L1 entered in. Now I want to do that T interval again. So I go to stat, over to tests, option number 8. So this time though, I want the input to be data. So I hit my left arrow and I hit enter on data. Now I put my data in L1. Very good, that's where it is. So it's in L1, good. So leave L1 there as the list. The frequency is 1 because each of those data items happens once. The confidence level is 0.90 this time, or just 0.9. Then hit calculate, and we're off and running. So I got 14.111 and 19.032. And lo and behold, we're good. We just had to take that one extra step and enter that list in. So 90% there because I got a 90% confidence interval, 10% left over. So there we have it. And there's number 6. So 7 runs the same exact way as 6. So I'll skip it for now. Let's look at 8. So the effectiveness of a blood pressure drug is being investigated. An experimenter finds that on average, this reduction in systolic blood pressure is 29.7 for a sample size 27, a standard deviation of 20.7. Estimate how much the drug will lower a typical patient's systolic blood pressure using a 95% confidence level. All right, so it's basically, this is the T interval all over again, right? So I go stat, over to tests, T interval again. I don't know the population standard deviation. I only know the sample standard deviation. So then hit 8 This time I'm entering stats. So I got to go over to stats and hit enter. And then I enter what I know. So I know my mean is 29.7. I know my sample standard deviation is 20.7. I know I surveyed 27 people and I want a confidence level of 0.95. Calculate it, and it's going to give me the lower bound and upper bound for that mean. So we're 95% certain that that drug is going to lower blood pressure by between 21.5 about and 37.9. So enter those two and away we go. Okay, 9 is like the same, except it wants you to enter an interval. Yeah, we better do 9 and 10. Because 10 is tricky. I'm just going to keep pushing forward unless you all have questions. This one, I ought to estimate the mean temperature with the following sample temperatures. So I got to enter the data as a list again. So I go stat, edit, clear enter on L1, and then enter that list. Hopefully I don't get any of them wrong. All right, there we go. I entered 11 sample temperatures. Hopefully that's correct. Now I go to stat again. T-test or T-interval, right? The T-interval, I'm going to enter data this time. I had to enter a table, so I'm going data, enter. Yep, list is L1, frequency 1 apiece. Confidence interval 99%, so I go to 0.99, calculate. This time you basically enter exactly what they have up there. You're going to enter exactly what they have right here in parentheses and everything. Okay, too bad we couldn't copy and paste it. So here we go. I got parentheses 59.347 comma 92.235. And I got it wrong. I wonder if my list was okay. So then we go check the list. Oh, you know why it's wrong? Because I have 92.235. 0.235. Hey, troubleshooting. The last one on this wants you to enter this confidence interval differently. It doesn't want the lower bound and the upper bound. It wants like the mean plus or minus whatever the error is. We're going to do it the same exact way, but then we're going to have to figure out that error. And the error basically is going to be half of the width of the interval is the error. Okay, so here we go. Go to stat, over to tests, T interval again. This time I'm entering stats. And my mean is 39.7. Standard deviation, $10.40. We surveyed 31 people. And we have a 95% confidence level. Calculate. So this is going to be the interval they're giving you. That's going to be the interval right there. 35. So let's see if my pen wants to write today. 35.885, comma 43 38.515. There's my confidence interval, but it doesn't want me to enter it in that form. It wants me to enter it in the mean plus or minus the error. So the mean's 39.7. That's what goes right there. Then the error, we basically got to figure out what's halfway between those two numbers. Like how far apart are 43, let's see, 43.515 and 35.885 are going to be 7.63 apart. So if I cut that in half, if I divide that in two, then it's 3.815. That's the EBM. That's the error. Okay, what does EBM stand for again? Let's see, the standard. Nope. All this terminology. The error bound is what EBM stands for. So we're going to do 3.815 right there. It's basically going to be half of the width of the confidence interval is going to be the error, because you go mean below that number or mean above that number, and that's where the confidence interval comes from. Okay, that is it with the first assignment. You all have any questions before we move on to the second one? Yeah, you can ask questions again after I'm done going through them.
For questions like number 4 through 6, when you're finding like on question C, how do you like I understand how to find like the first percentage, but then I always find trouble to do the second one.
So you just do 100 minus the first one.
Oh, okay.
Because they have to add up to 100 every time.
Okay, then.
So
Thank
98
you.
and 2, and then the next one's 95 and 5, right? They always add up to 100.
Okay, perfect. Thank you.
Excellent. Good question. Okay. Second section. So we'll go to 8.8b. All right, so we're doing, this one's all about confidence intervals for proportion. That's like, you can survey a bunch of people. Like today we have elections in Oregon, right? We're electing school board members today. So you could actually go sit outside a drop box. Then you could say, who did you vote for? So-and-so or so-and-so, right? And then like say 50 out of 200 people say, well, I voted for this person. Well, then this proportion will be 50 over 200 or 25%. So that's basically what the proportion is. So here we got a news group is constructing a 95% confidence interval for the proportion of all Americans who are in favor of the New Green Initiative. Of the 586 randomly selected Americans surveyed, 407 were in favor. Round answers to 4 decimal places were possible. So with 95% confidence, the proportion of all Americans who favor the New Green Initiative is between. So in this one, we're going to use a different one, because we're not talking about a population mean anymore. We're talking about a population proportion. So the proportion of all Americans. So we use a different test this time. You find it in the same place. So we go stat over to tests, and this one's going to be the 1 prop z int. And this is the one we're going to use for every one of them. Where is it? There it is. It's A. 1 prop z int is big A. Unfortunately, it's not a number. I guess can I just type big A? No, I got to scroll down and do it. So hit enter, and it's going to be much the same thing that we entered last time, except we're going to have to enter less. So X is going to be the number of people who voted yes. It's like, remember we talked about the binomial theorem a few weeks ago? not the binomial, it's the binomial distribution. Sorry, getting my classes mixed up. Binomial theorems, math 111. But we did binomial distribution. We talked about the probability of success. So the probability of success in this case is going to be 407 over 586. So I hit 407 is going to be the number of people that answered yes in favor out of 586. And then you just put the confidence level of 0.95 and calculate. And there we have it. So the true population proportion, we're going to say, is between 65.7% and 73.2%. Based on our survey, we're saying with 95% confidence the true proportion of all Americans who favor this is between those two values. And then this is the same thing. We're 95% confident, 100 minus 95 is 5. So same thing we were entering in the last one. All righty, I think 2 and 3 are exactly the same. So let's do one of those. Let's do number 2. So a smartphone manufacturer is interested in constructing a 95% confidence in, why don't we just enter these right now? 95 and 5, right? We'll just enter those, get those out of the way. Okay. So 81 of the 1672 randomly selected smartphones broke before the warranty expired. Round the answers to 4 decimal places. Okay, so stat, test again. Now I got to scroll down a bunch of ways. Scroll. Down to prop Z int. And then I have 81 out of 1672. My confidence interval is still 95, so I could leave that there. Now I can calculate. So between 3.8% and 5.9% of all smartphones will break within the warranty period. We can say that with 95% confidence. Okay. So number 3 works that same exact way. All right. Moving on to number 4. In a recent poll, 150 people were asked if they like dogs, and 80% said they did. Find the margin of error in this poll. So we got to divide to get that, or do 0.80 times 150, because when we enter this, we need to put that whatever the X value is, right? So we got to do 80% of 150. I believe that's 120. So then when I do my test here, the prop Z int, I'm going to have to enter 120 in for my X. So we go to stat, over to test, down to our friend down there, prop Z int. So I'm going to put 120 at over 150. So N is 150. My confidence level this time is 0.99. So the deal is 2 on these problems. So I came across it when I did this assignment earlier, is if you take whatever the 0.8 is, the 80% times the number, and you get a decimal, you got to round it to the nearest whole number. All righty, round to the nearest whole number. So I go down to calculate, and there's my confidence interval. That p hat 0.8, that's the 80%, right? That's the 80%. So now I'm going to, it asked me for the margin of error. Excuse me. So now I got to do that I have to do that subtraction. So here's my confidence interval, 0.71587. And then my and 0.88413. Then I got to find out how big that interval is. So I subtract the two. So 0.71587. Whoops, I'm gonna get a negative number, 0.88413. So the spread is 0.16826. Divide that by 2, and then that is going to be the margin of error. I divide it in 2 because it's the sample proportion plus or minus the margin of error. So the confidence interval represents 2 margins of error. So 0.08413, and we got it. So those are pretty tricky. If we got a similar question, some number 4s are completely different than this. I mean, see, that's completely different. So this one, you might get this one. 112 students at a college were asked whether they had completed their English 101 course. 57 said yes. So the best point estimate for the proportion of the students who have completed their English 101 is just going to be 57 over 112. So you just calculate 57 over 112. And that is going to be our sample proportion. And we get 0.5089. Okay, so that's just another thing that may happen on number 4. All right, number 5 is just like 1 and 2. You do the prop z int. So we don't need to do number 5. Number 6, well, number 6 confidence interval. Here we go. Let's do this one, because this one they want you to enter the interval instead of just entering the 2 numbers. So it's the parentheses and everything. So stat tests down to where we're going. Prop z int. X is 58 successes out of a sample size of 117. The C level is 90%. Calculate. And then we're going to enter it as an interval. So 0.4197, comma 0.57176. All right, but it's the same exact process that we've been using. 7, same thing, except you're just going to enter the 2 numbers we came up with. Same exact question. Number 8 is interesting. Let's take a look at number 8. So express the confidence interval in the form p hat plus or minus e. So the confidence interval, the p hat or the mu, whatever, is always right in the middle. So to do this one, I would add those 2 numbers up, 62.1 plus 79.7. I forgot parentheses, so I'll hit enter first and then I'll hit divide by 2. So 70.9 is going to be that number right there. And then I can just do, what's the error? So the error's got to be like the difference between that 70.9 and one of the 2 from the confidence interval. So I could just do 79.7 minus 70.9. And that's going to be my error is 8.8%. All righty. So just a different way of expressing the confidence interval. Alrighty, so this assignment hopefully isn't seeming too bad to y'all. It's the first two aren't bad. The last one's pretty tricky. The 8C one's pretty tricky. Well, what questions from this one before I move on?
My number 5 is like a full like table.
Let's put that on the back burner. Well, actually, do you mind sharing, Estelle?
Yeah, I can do that.
No, let me stop sharing mine. This would benefit our whole video here if you show yours. Plus, you're gonna get a freebie. You'll get one right.
Perfect.
All right.
Okay.
Okay, so giving a test to a group of students, the grades and gender are summarized below. Let P represent the population proportion of all female students who received a grade of B on the test. Okay, so how many female students do we see? We see 38. So my N is going to be 38. How many of them got B's? 6 got B's, so X is going to be 6. And then your confidence interval is going to be 0.99. So you're going to do the one, what is it again? The one prop Z int with those in there. And then whatever you come up with is going to be that's going to be your winner. Yeah, so that was the other one for number 5. Yeah, that's weird that they're so different. Usually they're pretty similar questions.
Yeah, no, they were completely different. The CI is just sea level, right?
The CI is the confidence interval. What is
And
that?
sorry, Car. In the calculator, that would be sea level. I would enter
Yeah.
0.9.
Yep.
Cool. Cool. Should I stop sharing my screen?
Or you could put it in, make sure we're correct.
Okay.
Prove to the world that we're right here. Well, that's a pretty wide interval.
Perfect.
All right, good. All right. So, ready to move on, you two?
Yep.
Yes.
Very good. So the last one gives you some info and you got to figure out how big a sample you need to take. So you're kind of going backwards. So a political candidate has asked you to conduct a poll to determine what percentage of people support her. If the candidate only wants a 2% margin of error at a 99% confidence interval, what sample size is needed? Oh, what did I do? I hit the wrong button. I want to hit annotate. Here we go. All right. So there's 3 formulas in play here. 3 formulas in play. So the first one that we're going to use in this one's got to deal with proportions. All right. So it's N is going to be the size of the sample, 1/4. And then we're going to have our Z alpha over 2 number. That's going to come from the confidence interval. And we're going to square that. And then we're going to divide by your error bound squared. So we want a 99% confidence interval here. So we basically 99%, we're going to have 99% between those 2 outer lines. So you got to have 99% from here over to here. So you're going to have 1% in either tail. So 0.005 in either tail. So when we calculate this Z alpha over 2 number for this one, we're gonna do Z 0.005. So here's what it's gonna look like. We're gonna first use inverse norm. Okay, so use inverse norm. Remember, inverse norm gives you what the Z number is if you know the percentage, if you know what's in the tail. So we use inverse norm to find Z alpha over 2. So here's what we're going to do. Here's how it's going to look. Z inverse norms in the distribution menu. So we got to go to second DISTR, and it's option number 3. So we want an area of 0.005. 0.005. The Z number is the standard normal distribution. So leave mu at 0, leave sigma at 1, and then we go down to paste, and it's going to give you your Z number. So we're going to use that negative 2.576. Now here's the deal. We know we have to square that. So what I would do, because I got to do this calculation now. We're doing this calculation right here. So I know I need to square that. So I'm just going to hit x squared. So now that's your Z alpha over 2 squared. I'm going to divide by my error bound. So that's going to be the 0.02 is my margin of error. So I go 0.02 squared. Then I got to multiply that by 1/4. I'm going to talk about that 1/4 thing when we do a different example. And then always round up on this one. Always round up. Because the 81/100ths of a person is a person too, right? So 4147 is going to be my number of people that I need to survey in order to get that margin of error at 99% confidence. Okay, we use this formula. Use this when the sample proportion is unknown. We don't know any sample proportion on this one. So we're going to use, we use the 1/4. In that case, there's going to be somewhere we know the sample proportion. Okay. Very tricky. Very, very tricky. Let's do 2 together. It's basically the same problem as number 1. So I'm going to leave my drawings up there, except this time they want to obtain a sample. You would want to obtain a sample estimated population proportion. At this point in time, you have no reasonable preliminary estimation for the population proportion. You see those words right there, and that tells you you need to use the 1/4 one. There's going to be a different formula if we know the sample population proportion. There's a different formula, unfortunately. Okay, this time I want to be 80% confident. I want to be 80% confident. So our tail is not going to have 0.005 anymore. 80% confident. So between these two numbers is 80%. Okay, that means the tail's got to add up to 20%, right? So I got to have 10% in each tail. Got to have 10% in each tail. So when this time when I do the inverse norm, I got to use 10% and not the 0.005. I'm going to use 0.1. So here we go. Second distribution, number 3. My area this time is 0.1. Go down below. It's going to be much closer to 0 than the negative 2.576. So there's my Z number. So if I follow the same process, I square that. So hit x squared. So that squares my prior answer. I divide that by my error bound squared. So that's 0.03 squared. And I multiply that by 1/4. And then my sample size is going to be 457. 457 this time. All righty. Would it be worth seeing one more?
If it comes out negative, does that mean we did something wrong or?
Inverse norm on say?
No, after doing the 1/4 and the,
No, it shouldn't come out negative unless you did not put the negative number. Did you actually type in the negative number?
no, I copied it.
You copied the negative number and then just hit the square button.
Yeah.
So what it's doing is it's squaring the number first and then putting the negative. So what I would say, if you do it your way, just ignore the negative.
Okay.
Ignore the negative. So put that, make sure it works for the one you're doing.
Yeah, it's not working.
Let's get through a few more, then can we backtrack after? I'll stop I'll stop the record and then we can look at yours together
Yeah, that's okay.
in a few minutes. Okay. A political candidate has asked you to conduct a poll to determine what percentage of people support her. If the candidate only wants a 7% margin of error at a 95% confidence level, what size of sample is needed? Okay, so same thing here. This time though, our confidence interval is different again, isn't it? 95% confidence interval. So basically, we got 95% right here. So then we need 2.5% on in each tail, right? To get me to the 100%. So then when I do my inverse norm for this one, so second distribution down to number 3, my area is going to be 0.025. Paste it. So there's my inverse norm number. So that's my Z number. So I square it. So I'm gonna say if you get that and then you just hit X squared, that's gonna take care of the negative. It just takes the prior answer and squares it.
Oh, okay.
So you won't have to worry about the negative. So I divide that by 0.07 squared this time. Still don't know the sample proportion, so multiply by 1/4. So 196. All right. Like I said, Monte, we'll go over yours because I wanna share my screen when we go over yours so I can show you on the calculator. All right, so let's go on. Number 4. Let's see how this differs. You want to obtain a sample to estimate a population proportion. Based on previous evidence, you believe the population proportion is approximately P equals 0.76. So here's the deal, everybody. If they give you the P, it's a different formula. So when P is given, use N equals, let me get this right, Z alpha over 2 again. Squared times P hat times Q hat. So that's the sample proportion times the sample like opposite of proportion, like the failure rate, the success rate times the failure rate. So the reason they use 1/4 is because 0.5 times 0.5 is 1/4, and 1/4 is the biggest number you can have. So it's going to result in the best estimate. But if we know the 0.76, see if I did 0.5 times 0.5, you're going to get an n that is higher. If I know the sample, then I'm going to, n is going to be lower. So then over the EB squared again. So there's my formula. So first things first, I gotta have 99% confidence. 99% confidence. So we could draw the little normal curve again. So 99% right here. That means the other two tails got to split 1%. So we're going to have a 0.5% on either tail. So then I can go to second distribution down to inverse norm. I want 0.005, which is the decimal equivalent to 0.5%. And there's that number again. So my formula has me squaring that. So I just did x squared and then times my p-value, which is 0.76, times my q value. Remember where q hat comes from. P plus q always has to equal 1. So q is going to come from 1 minus p. So 1 minus 0.76. So that's going to be 0.24. That's what I'm going to enter over there for my q hat. Then divided by the error bound squared. So 0.025 squared. Then I get 1,937. So that's the sample I need in order to get what they're asking. We may as well do the rest of them, right? We're on a roll here. So the next one, you want to obtain a sample to estimate a population proportion again. Based on previous estimates, evidence, you believe the population proportion will be approximately 82%. All right, so 82%. Let's see, what color should I? How about this green one? Okay, so therefore my p hat is 0.82. My q hat then is 0.18 because they have to add up to 1. Then I want a 90% confidence. So 90% here. So 10% is left over. So each of the tails is 5%. Each of the tails is 5%. And then I just do the same process, right? Same process. So here we go. Second distribution, number 3. I gotta have an area of 0.05. So there is my number for the Z number. Then I square that, multiply it by 0.82, multiplied by 0.18, divided by my error bound 2%. I gotta have 999 people in my sample. Six and 7 go back to talking about population means. All right. For 1 through 5 were about the population proportion, the probability of success. Now we want to go back to talking about means. So you want to obtain a sample to estimate a population mean. Guess what? Different formula. So population mean. Our formula is going to be Z alpha over 2 squared times the standard deviation squared over the EBM squared. So the EBM this time is going to be 5, right? So it's different because it's not the percent. It's not the percent. It's the like a numerical standard deviation or numerical error, not a percent error. Okay. And then this right here is going to be 50.1. Then we got to figure out our Z alpha over 2 again. I got 98% confidence. So 98% here. So to get to 100, each of the tails has to be 1%. So I go inverse norm again. Same procedure, just slightly different formula. So distribution number 3, I want a 0.01. And we get negative 2.326, blah, blah, blah. Got to square it. Multiply that by the 50.1 squared. And divide that by my 5 squared. So I got to survey 544 people. Seven, same exact way. It's going to work same exact way. In fact, it's got 98% confidence again. So I could actually do that negative 2.32 number again. Suppose I didn't recognize that. I go to inverse norm. My area is 0.01 again. So there is my Z number. Got to square it. So I hit square. Times the standard deviation squared, 75.2 squared, divided by the estimates within $10. So the EBM is 10. Enter, and I got to survey 307 people. Always round up, remember. Always round up. Okay. So before I turn the recording off, Monse and Estelle, do you have anything? Or I'm going to turn the recording off and then you can ask away as well.